this video, we are going to have an introduction to inequalities. So what is an inequality? I'm actually going to be even more specific than that. An inequality expression, right, when we have a variable with it, it actually represents an interval of values. Interval is a word you're going to hear a lot from this point on in math. So what is an interval? An interval consists of blank values. It actually consists of an infinite number of values. And that's why we have to have a way of writing down an infinite number of things. We can't write them all down separately. We write them as either an inequality or there's actually interval notation. Today we're just going to focus on inequality notation. We have some symbols you've definitely seen before, like less than and greater than, less than equal to, greater than equal to. And don't forget not equal is also important, right? Inequality means not equal. So let's just get a little bit more familiar with this symbol. Now I know it says up here that it's less than, right? I don't get so hung up on the direction of them. I just think about what it's eating, right? I seriously go back to whatever it was, 3rd grade, when my teacher first drew this on the board, put some teeth on it, right? It's like an alligator's mouth. The alligator's always going to pick the bigger, tastier dinner, right? It's always going to eat the bigger number. So we wrote a little note about that over here. The open end, this is the open end over here, eats the greater value. So let's try this one, 7 and 3. Which of these numbers is the alligator gonna eat? Well, 7's the bigger number, so we would put this symbol in here, right? It doesn't even matter that this is called the greater than symbol. Obviously 7 is greater than 3, but it's more about where you're just putting the correct symbol in that matters right now. Okay, so here's what I mean by that. Every inequality can be written in 2 different ways. You can either use the less than or the greater than sign. It's just which things you put inside of the open end, right? So here's a sentence, all values greater than 5. So whenever we see all values, I want us to think about, well, that's something we don't know, and it could be an infinite number of things. Let's call that x. So all the values that are greater than 5, there's an infinite number of them, right? So that means we're comparing all of these numbers, these infinite numbers, and 5. Which one of these 2 things is bigger? Well, it says all the values that are bigger than 5. That means that x must be bigger than 5. But that's not the only way to write this sentence. What if we flip-flopped these around? Right? X is still bigger than 5. It still gets eaten, right? So everything flipped around here. So you can say it either all values greater than 5, or you could read it as 5 is less than all values, okay? So just remember that. There's always 2 different ways of writing it. I'm not saying that there's any way you want to write it, right? There's 2 very specific ways to write this as symbols, okay? Okay, so we have some delta math examples here. Remember that number lines are very good for helping us with inequalities, right? Especially if we have an infinite number of things, we can shade on them. But for right now, we're just going to go through a list of things. We're going to see which of these values make this inequality true, right? Meaning that if I plug this number, -12, right here for G, is -12 the smaller of those 2 numbers, or is -4 the bigger of those 2 numbers, right? Is that true? Yeah, of course that's true, right? -4 is right here, whereas -12 is right here. Whenever a number is to the right of another number, right, it's bigger, right? Bigger numbers this way, smaller numbers this way. All right, so I would check that off. Now, if we really want to get into this here, we could say, well, here's -4. All of the numbers that would be smaller than -4 would be to the left of it, right? So we're basically testing which of these are in this section. Like -9. Yeah, that's in this section, it's right there. -7, that's also right there. What about -5? Yep, that's close. And then we get into some weird ones. What about -4.1? -4.1, right? If you think of positive, here's positive 4 and 5. 4.1 is to the right of 4. But we're in the negatives now, right? Everything's going the opposite way. So it's actually to the left. It's more negative than just -4, right? So this is in that section. It's right there at the edge, but it is there. Just as -4.01 is also in that section, right? It's a little bit more negative than -4. All right. Same thing for this. It's a little bit more, the tiniest bit more negative than -4. Now, what about -4? Is -4 less than -4? Well, no, -4 is equal to -4. No, I'm not going to check that one off. That is not true. What about -3.999? Well, remember, in positives, 3.99 would be to the left of 4. Here, that's going to be the reverse. It's going to be to the right. So it's going to be right there. It's not going to make it in. Neither is this. Neither is this. Let's see, -3. -3, that's not going to make it. -1, that's right here. Nope, that's not making it. 1 and 4 are definitely not making it. All right, so we've checked off all the values that are on this list that make this true. But we couldn't possibly check them all off because there's an infinite amount of them. All right, there's one other thing we're going to work on today. It looks somewhat like an equation, right? If you picture this less than sign as an equal sign, we would be able to solve that. We're going to wait to solve these inequalities today, and instead we're just going to test out to see which values work. So, which of the following are solutions? Solutions mean make this true. Make this work. So we're going to plug in. So we're going to take our -6 here, and we're going to plug it in for x. Okay, so we have a number is less, we have -5 is less than, and we need to know what number this is. So let's go through these steps. 4 times -6, that's -24. And now let's add the 10 to it. We get -14. Okay, of these two numbers, is -14 the bigger number? No, it's not. That is not a solution. This is false. That's how we're going to work on these today. Let's go to the next one. -5 is less than 4 times 4 plus 10. Let's check this number out now. We still have the -5 here. This is a 16 plus 10, so we get a 26. All right, and we ask ourselves that question. Is this true or false? Which of these is the bigger number? Is this eating the correct one? Yeah, it's eating the 26, right? This is true. So we have a solution right now. But remember, this is infinite solutions, so it could have this also working. We're going to plug in that last number and see what we get. Okay, so this is a -28 plus 10, which is -18. Is -18 bigger than -5? Nope, not when these numbers are negative. That's a false. That's out. So in this situation, just the second choice was a solution. But they all could have been solutions. It's possible. Okay. Let's switch to another idea right now. Making a graph of these intervals can be very helpful when we get to solving. So we need to learn a little bit more about some symbols that we want to use, okay? Whenever we see less than or greater than, just like in this first example here, x is less than -10, we're going to use what we call open circles on the number line. So I'm going to put the -10 on the number line, and it's going to get an open circle. What that means is that it is not including the number. Open, not including. Okay, I will come back to these in a moment. Let's come back to our graph over here. So we now need to shade this in. We want to shade in because there's an infinite number of things, right? So that bar, like these examples down here, represents that infinite set of values. So x is less than negative 10. Which side should I shade? X is all values. So do we want the ones less than negative 10, right? Smaller or bigger? Well, we want the ones smaller, so we're going to shade this direction. Just like that. That's how we do it. Okay, so for the next example, notice that our circle is actually filled in. We call that a closed circle. And what that means is that we do want to include. We are including the number there. So -5 and some interval. That'll be x. Which of these two things is the bigger? The bar of values or the -5? Well, these are bigger because they're to the right. So the x, in this case, must be bigger than -5. If you wanted to, you could write it this way, right? The opposite way here. We could say that all values greater than -5. Either answer is correct. Except we forgot, if these are closed, we want to include that value. So we're going to put equal signs on either the less than or the greater than. Whichever one you used, make sure it has that equal with it. All right, I'm going to pause here and see what you can come up with for this interval. Okay, so we have an open circle on 3, and we have an interval to the left of 3, right? We're going to call that x. This is definitely smaller than the 3, so the 3 is going to get eaten. So x is less than 3, but you could also write that the other way if you chose to do that. All right, we got one more topic, and that's what do you do when you have a compound inequality? It's like, what is a compound inequality? What it is basically an inequality, but it's made up of two inequality statements, and they're joined together by either the word and or the word or. When we see the word and, we want to remember that it makes both statements true. But or, it makes either statement true. Okay? So here's what we're going to do. I'm going to do the and first. When we work on and, sometimes it helps to do a little side work over here. All right, so we want -6 less than x, and x has to be less than -2. And we have to make both of these true. It can't be either of them, okay? So let's put this on a number line. We got -6 and -2 as important numbers. Less than means that we're not going to use a filled in circle, right? We're going to open. And -6 is less than x. So we want the numbers bigger than 6. So I just did this one in red. I'm going to switch over to green for this one. Open circle on -2. But all of the numbers have to be smaller than -2, right? So we want to go to the left. Our answer, let me use pink here. Our answer is the overlap, okay? So let's come down here. Our answer is -6, open circle, in between that and -2 with an open circle on -2. What's happening there is that you're picking values that work in both of these inequalities. For instance, -4 is in between those. -4 happens to be bigger than -6, and it's also less than -2. So and is about overlap. Or is easier. Or you just put both of the intervals on your graph. So let's do that. We have x is less than or equal to -7. Okay, so that gets a closed circle. And we want the numbers that are less than this, right? So we're going to go to the left. Done. That part's done. The or is telling me that both of these can go on there. I don't care about the overlap. All right, so then x is greater than or equal to -4. So -4 would be on this side of -7. It's equal to, so we're going to fill that in. And we want the numbers that are bigger. The numbers have to be bigger than -4, so we're going to go to the right of -4, those bigger values. So that means that the numbers can work in either one of these intervals. So see how different those look? So give this one a try now. What would this look like? Look how it's written, right? It can be written either way. It can either have the word and, or it can be sandwiched in between these numbers. So your answer should be an interval between -4 and 4 and filled in circles. Just like that. It is easier when the word and isn't there, right? We can already see like that sandwiching. All right, pause the video here and come up with an interval that represents this picture. All right, so hopefully you use the numbers 5 and 9 and realize that if we have two separate intervals here, we want to connect them with the word or. So this first interval, we want to compare numbers with 5. The numbers are less than 5, right? So we're going to eat 5. And then the other one is 9 and x. And 9 is the smaller of these, right? It wants the bigger value, so x is going to get eaten. And now the last thing that we need to do is remember that these were closed circles. So we want to add an equal sign. So now these become a less than equal to symbols right here. All right, good luck with your practice.